different devices used in network connection in your college campus. See, mainly in our college campus, whatever the whatever the devices they are calling, they are generally common. So in our labs we are using host machines, we are using switches. Then definitely we must be having a router to send our information outside the network, and definitely there must be a default gateway through which we must be connected uh, to the outside internet network now. So whatever we are sending, it is going through that, and it is coming back. So those devices, and then when we are using those devices, we are using different types of cables to connect them. So we are using twisted pair in our college. Okay, I know you have not been to the labs and all these things. For this subject, generally we conduct experiments in the lab, and we show you, we demonstrate all the devices which we are having. And then if we are having somewhere that Wi-Fi, wireless connection, then what we must be using? We must be using that access point, that modem, wireless router. Okay, and in our devices we are using network interface card, NICs, Ethernet. So you all these devices which we are using, so you have to write all about all these devices. Okay. See, generally what we do in this semester now, when our in regular time, all those devices, all those things are shown to the students. Okay, we have a few devices in the spare, and all the configurations you can go and see in the lab. You can go and see in the server room, whatever things are available. But this time we are not going to the college, so that's why it's not possible for you, for us to show you or demonstrate all those things like what we are using. So these things are common for all type of network. Only thing that can change is the topology they are using. Okay, if they are using a star topology, then they must be using switch. Generally we can use hub in the switch, in the star topology, but nowadays switch is used because switch is performing multiple tasks. Okay, switch is much smarter than hub, and that's why we use two switch in every lab. Okay, and that is 24 port switch, so it means we can connect 24 devices. And we are in the lab, we are having 25 devices plus three connections, three spare connections are also there. So we are using two switches, and those switches are connected, then all those switches they are connected together, and then they are connected to that our server, that router in the our server room. Okay, so on the first floor we have our server room. So you have to write about all these devices. Excuse me. So screen is visible now. That paper is visible now. Okay. So in yesterday's class, we discussed about transport layer, then TCP protocol header. There were 6 flags we were using. Okay, can anyone tell the name of those flags? Even if you remember one name of any flag, you can write in the chat box or you can unmute yourself or tell. In that header, we were using 6 flags. Yes, finish, very good. SYN, yes. Urgent, very good. Yes. 3 more. See, it provides reliable delivery. So acknowledgement, yes. Push, yes, very good. One more. Mm, One more flag was there. Reset, RST. Okay, to reset the connection. Okay, so 6 flags used in TCP header. What I'm writing is visible now clearly, paper and all everything, or need any adjustment? Yes, tell me, is it visible? It's clear? Yeah, thank you. Okay, so these 6 flags are urgent flag, then our acknowledgement frame, oh, sorry, flag, then push flag, then our reset, and then SYN, and then finish. Okay, these are 6 flags which are used in the TCP header. Now today we will see the uses of these flags, how these flags are used for connection establishment, connection closing, for providing acknowledgement and all that. Okay, so these flags are very important. Urgent flag is used when we want to send some data urgently, because yesterday I told you TCP is byte oriented. Okay, byte oriented, and it stores that data in the buffer, and after receiving the byte information from the application layer, it converts that data in the form of segment, and then those segments are transmitted. Okay, and it is sending the data in a sequence, byte by byte. Okay, so if you want to send something urgently, so as per sequence, that will be in the last. Okay, so when everything is being delivered, after that your urgent data will be delivered, then there is no point of that urgent data. So for that purpose, we can set this urgent flag to 1, and in the urgent pointer we can set the location, that from which particular location or from which byte that my data is urgent. Okay, so that data which is urgent, it is put in front of the old data, whatever is in the buffer, and then it is transmitted first. Okay, then acknowledgement, if you are acknowledging some segment which is received, then acknowledgement frame is used, a flag is used. Push flag is used when we want to use this TCP as a interactive option. Okay, uh, interactive option, like when we are chatting, or when our thing is like whatever command I'm giving here, that should be executed, and immediately I should get response for that command. Okay, so in the telnet or in some other application where I am just using this for interaction, so this push flag we can set, our data will not be stored in the buffer. Okay, And generally what TCP does, TCP takes the data, stores it in the buffer, process it, and it delivers to the application layer, but whenever the application layer is ready to receive, or it is when it is convenient for the TCP to deliver this data. Okay, but when we set this push flag to 1, it means do not wait, do not store that data, immediately process and deliver it. Okay, so that's why we can use this push flag. Then reset flag is used to reset the connection. Syn is used to start the connection establishment process. Fin is used to finish or close or terminate that connection. Okay, so in TCP I told you two characteristics of TCP. What are these characteristics? That it is a reliable and connection oriented. TCP is reliable and connection oriented protocol. It means when we are saying connection oriented, it means prior connection establishment is required for transmitting the data. Okay, this is like dialing up the phone number, and when you are connected, then only you can communicate. Okay, so today we are going to discuss TCP connection establishment. Okay, so we are going to discuss a TCP connection. Okay, it is very important from the Viva point of view or in the exam point of view also. Okay, so it has three phases in the TCP connection. First phase is connection establishment. Okay, so first connection should be established. Okay, establishment. The connection establishment process, this we call it as a three-way handshaking. The three-way handshaking. This three-way handshaking is very important. Okay, very, very important. Three-way handshaking is a process of connection establishment in TCP. Okay, in that what there are, we communicate using client and server. Okay, so server cannot initiate a connection. Okay, if we want to search something on the Google, so Google is a server and our machine is a client. Okay, so Google is never going to reply us something. Google is never, that server is never going to initiate a connection that will say, okay, you want to search something about cnnd, lo ye tumhara response. No, we have to ask. Okay, then only that will server will respond. So server and client always initiate the connection. Okay, and server is ready to accept those connections. So when server is ready to accept that connection or any connection from any client, so it informs its TCP, the TCP working on that server, it informs that TCP that I am ready for accepting the connection. So this is called as passive open. This thing we call it as a passive open. Passive open means the server is ready to receive the connection. Okay, then when client initiates the this TCP connection, okay, so it will send a request to server that I want to establish a connection, I want to communicate to you, are you ready, will you communicate with me? So that is active open. So active open is when client initiates that process. Okay, sometimes two machines they want to communicate, they are not client server. Okay, they want to communicate to each other, so both machines they can start this connection establishment process. So that is known as simultaneous open. Both machines they send request. Now how this connection establishment phase takes place, or what is this three-way handshaking? So when this client machine wants to start or establish a connection, it will send a segment where SYN flag is set. Okay, SYN flag is set to 1. Okay, so that is set to 1. So that is known as SYN segment. Okay, so this we call it as a SYN segment. So the machine, the client machine, which wants to transmit or sorry, establish the connection, want to transmit the data. So it will send a segment where SYN flag is set. Okay, If the server machine is ready to receive that, ready for connection, so that will reply with SYN plus ACK. Okay, ACK segment. So SYN flag set or ACK is the acknowledgement of this segment which we transmitted. Okay, so this will be replied from the receiver side. And after that, the machine which wanted to establish the connection again will send ACK segment in response to this segment as a acknowledgement for this segment. After that, connection will be establishment. So the process of sending these three segments is known as three-way handshaking. Three-way handshaking. The client machine or the machine which wants to establish the connection sends SYN segment to the receiver machine. Receiver, if receiver machine is ready to accept your connection, then that replies with SYN plus ACK segment, and then the client machine sends with the sends ACK segment, and after that connection is established. So this way, this process we call it as a three-way handshaking. Is this concept clear? Now I'll show you this with the example, this with the diagram. Okay. So now suppose I'm taking this as a client, and this is our server. I'm using just minimum data of the header which is required just for this. Okay, along with what we are going to mention, there are many other things which are sent. So first, if this client wants to initiate a connection with the server, so it will set SYN flag, and it uses a sequence number. We know that in this TCP there is a sequence in the header format, there is a field sequence number and there is a field acknowledgement number. Okay, so it will prepare a segment. In that segment, a sequence number will be given. So suppose I'm using sequence number 8000. Okay, sequence number flag will be set, other values of the header format will be set, and in this SYN flag is set to 1, and this is transmitted to the server. Okay, this is transmitted to the server. Okay, so this is known as SYN segment, and here the the server is ready to receive the connection. That's why it is passive open. The connection is in the passive open mode. Now client initiated that process, it is in active open mode. So it will send this SYN segment. Now this server, if it is ready to receive the connection, it will reply. Okay, so it will reply. Now it has to provide the acknowledgement also. So it will use acknowledgement number also. Okay, so it will use a sequence number for this segment. So suppose it is using sequence number as a 15,000. Okay, then acknowledgement number for this segment, it means it has received 8,000. So acknowledgement number will be always +1. So acknowledgement 8001, and then it will set acknowledgement flag to 1, then SYN flag to 1, and it will transmit this segment to the client. So this we call it as a SYN plus ACK segment. Then client will reply to this segment as acknowledgement for this segment. Okay, so it will send back acknowledgement. Now this is only acknowledgement segment. So acknowledgement segment is not given as a separate sequence number. Okay, this SYN segment, it is not carrying any data, but still it will consume one sequence number. We have to provide a sequence number to this SYN plus ACK. It is also not carrying any data, but it is carrying SYN information. So that's why this is also given a sequence number. Any segment which carries only acknowledgement is not given a different unique segment sequence number. Okay, so in this the sequence number will be same as the previous one. So this acknowledgement frame is not going to consume any sequence number. So sequence number will be same. Then acknowledgement we have to provide for this. We received 15,000. So we have to provide the acknowledgement as a 15,001. 15,001. And in this acknowledgement frame flag will be set to 1. And it will be given to this server. Okay. This segment is known as ACK segment. Yes, ये समझ में आया? किसी को डाउट है? This process, the complete process is known as three-way handshaking. Any doubt in this? Is this clear? Should I repeat something? This is very important.
Ma'am, will you explain again three-way handshake?
Yes. In three-way handshaking, client machine request server machine, because if client wants to communicate, then it has to request that server machine, because connection, this TCP is a connection oriented protocol. This is like, if we want to come, I want to communicate to you, I have to dial your number. Your phone should be uh, uh, on, and it should be in the network mode. It means it is ready to receive my connection. Then your phone should ring, then you pick up the call, then we are connected. The same way we are doing this thing here. Okay. So here this client is asking the server that it wants to communicate to. So that's why it send this a segment where SYN flag is set to 1. Okay. And this segment is not carrying any data, but it is carrying SYN flag information. So that's why we have to give a sequence number. Okay. It will consume a sequence number. SYN segment, wherever you are sending, it will consume one sequence number. Okay, you have to provide a unique sequence number for this segment. Now this is received by this server. Now server will reply. If server is ready to receive the connection, then it will reply with the SYN flag and acknowledgement. Acknowledgement of that previous, that I received your SYN and I am also ready. So that's why SYN. So here two flags will be set to 1. Acknowledgement flag and SYN. Again, it will consume a sequence number. So you have to provide a sequence number. Okay. And acknowledgement number will be always one more than whatever you have transmitted. One more than that, or what the next you are expecting. The next sequence, what you are expecting. That 8001 means I have received your information of 8000. Okay. Then client will reply with the acknowledgement of this. Okay, that I received your this SYN and ACK segment. So here, but on not only in the connection establishment, later on also when you are transmitting the data, if you are just sending the acknowledgement, then the acknowledgement segment is not going to consume any sequence number. So in that you can put the previous segment sequence number. Okay, so it is going to use the previous segment sequence number, and acknowledgement is of this acknowledgement. So sequence number of this segment was 15,000. So acknowledgement is 15,001, and acknowledgement flag is set, and now the connection is established. So this whole process is known as three-way handshaking. Yes, still any doubt? Should I repeat something else? So once this connection is established, after that they can start transmission of the data. Transmission can be started. Is this clear? Can we proceed? Or any doubt in this? Should I repeat something? Yes, no? Okay, at least say yes or no. It's, if it is clear, then we can proceed, no?
Yes, ma'am.
Okay. Now, this same thing of TCP can be used for attacking the machines. Okay. That is known as SYN flooding attack. Okay. This same process of connection establishment, which is used in the TCP, is used for attacking the machine. Okay. So by attacker. So it is known as SYN flooding attack, and it is a type of security attack, we call it as a denial of service. Okay, there is a DOS attack, denial of service. So there are many mechanisms to perform this DOS attack. SYN flooding is one of them. Okay, so if you want that some server should not respond or the some server should be down, okay, you want to make some server down. So generally, what attacker will do, they will do IP spoofing. Okay, IP spoofing. So they will spoof the fake IP, and from those fake IPs, it will send SYN segment to the server. Okay, to the server. So when server is receiving SYN segment, what it will do, it will reply with the SYN plus ACK segment. And when it is replying, that time resource is also occupied. Okay, so what those resources, it will create that communication table, because when it is receiving the acknowledgement, after that data transmission should start. So server should know na किससे किस क्या data transmit करना है. Okay, कौन सा client से क्या request आ रही है. So for that, it makes a communication table, so that because server is receiving requests from multiple devices, multiple clients. So if I am asking for facebook.com, or I want to download something from the Google, that response come to my machine only. So for that, the communication table is prepared, okay, for every this SYN, so that it can keep a track to which machine what reply, or which machine is asking what type of data. Okay, so it prepares a communication time. Then it will set the timer. Okay, timers also, because timers are required, it provides reliable delivery. So if your timer expires, you have to retransmit. So that timers, setting the timers. Okay, so when it is setting the timer, again some memory is consumed. So all those things will done, and SYN ACK response will be provided. But the IP from where this SYN segment came, that was a fake, because that was spoofed. So this segment will be lost, it will not be delivered. Then it will not receive acknowledgement back, is not received. It is half open connection. Half open connection is here. Okay, then this, the attacker will continue to send this SYN segment from spoofed IPs continuously. Okay, so what this server is doing, server is having multiple half open connections. Server is having multiple half open connections, and resources allocated to those half open connections, which are not useful, which are waste. Okay, and that's why the server is so overloaded that it's almost resources are consumed, and there are multiple half open connections. That time the server is not able to respond to its legitimate customers, those who really want to establish a connection, because server is not having resources. So that's why that is a denial of services attack. It cannot provide the services to the its legitimate customer. So that is denial of service attack. And this denial of service attack can be achieved or executed by multiple ways. Out of that, this SYN flooding attack is one of them. समझ में आया what is this SYN flooding attack? Yes.
Yes, ma'am.
Okay, so if you remember, when we did our Wireshark wala experiment, that time also, if you open some browser when your Wireshark is capturing the packets, okay, so that time if you look for HTTP packets, you will find out this SYN segment, SYN plus ACK, and after that data transmission will start. Even if you are opening google.com, okay, then also before opening the google.com, this process will take place. After that, whatever data you want to search something, that is your data, that is a communication. Okay, so the same, this process of three-way handshaking can be used for attacking purpose. Okay, now the connection establishment is done. Okay, so this is the first step of this first point in this TCP connection. Is then second point is data transfer. Once the connection is established, we can start the data transmission. Okay, data transfer. Again, this data transfer can be one way or two way. Only client is transmitting, and server is just acknowledging, or both way communication, that is possible. Okay. When we are doing this data transmission, here we can use push flag if pushing data. If we are using this TCP for interactive services, that time we can set this push flag to 1, that then TCP will not store our data in the buffer, or it will immediately deliver the data to the receiver side. Okay, same place, at the same place in this transfer data phase, we can set urgent pointer also. So urgent flag also can be set, okay, for urgent data if you want to send something urgently. This is like we started the transmission, and then I realized that I'm sending the wrong information. I want to abort that transmission, so I can close that by stop the transmission by using control C command, but the control C command will be in the last, it will be delivered in the end. Then there is no point. I already transmitted everything. So that's why that when I set urgent flag for that control C command, then that part will be put in the front of the buffer and delivered first, so that connection, that data transmission will be aborted. Okay, so for urgent data. So here we can set all those flags. Now this normal data connection. So here again I'm taking client and server. Okay, now here suppose we want to transmit the data. So suppose this data we are transmitting, in this I'm using sequence number 8001, because this 8000 I used here for this SYN. After that I didn't use that, so 8001 is a sequence number. Now I have to provide acknowledgement. So acknowledgement will be of that previous flag, whatever received, that pre 15,001 for this only, because after that I have not received anything from this. Okay, so 15,001. Then here, if acknowledgement flag will be set, okay, and if I want to push this is optional. Okay, if I want to push this data, like I am using this for interactive service. Okay, then that flag can be set, and here the data bytes, I will start the data. So this part contains the data, and suppose I'm sending 1000 bytes. So bytes will be here starting from 8001 bytes to 9000. So this data, these 1000 bytes I'm sending. So this is received by the server. Okay, then again, next part, next segment also I can send continuously, because that is a window size. Without waiting for acknowledgement, we can send the segments which are available in the window size. So next, till 9000 I have transmitted in the previous segment. So in this I will send the segment starting the byte from 9000. Okay, 1. So the sequence number is the byte, first byte in the data. So that sequence number is the first byte number in the data. So here sequence number is going to be 9001. I have not received anything back from the server. So acknowledgement number is the previous acknowledgement only, and flags can be set ACK and push flag, and the data part, I'm sending the data. So data is starting from 9000 to 9001 to 10,000. So 1000 bytes I'm transmitting. This is received. Now this server is replying with the acknowledgement. Okay, server is replying with the acknowledgement, plus it is also transmitting the data. Okay, not only replying, it is also transmitting the data. Okay, so here sequence number is going to be 15,001. Acknowledgement number is, see, we have received the data till 10,000. So acknowledgement number will be 10,001. It means I have received all your bytes till 10,000. I am expecting 10,001 byte. Okay, and it will set the acknowledgement flag, and after that it will set the data also. The data, it should be in the that no, here don't won't write here, and then data part here. Okay, so data, and it is sending 2000 bytes of the data in one segment. So 15,001 to 17,000, that part of the information will be received by this client. Okay. Now, if the client will reply, it will give a sequence number of 10,001. Acknowledgement number will be 17,001. Acknowledgement frame will be set. Okay. This is clear. This is a data transmission, data transfer. This is how. Any doubt in any sequence number or any number which we are using, or in the data part or in any flag? Is this clear?
Yes, ma'am.
Okay. Now, if you remember TCP wala header, that time there was one field window size. Okay, so the client and server, they both have window size. Window size is the number of bytes, or the number of segment, the number of bytes you can transmit without waiting for the acknowledgement. If you remember sliding window protocol of data link layer, so those same sliding window protocols are used here. Okay, so in that data part, it can advertise its window also. So if that buffer space is less with the client, so it can send. So that I'll tell you how it can send. Okay. Now this is second step in the TCP connection. Third step is connection termination or connection closing. So when the data transmission is done, the connection should be terminated. Not the data, it should be connection termination. Okay. Connection termination. So for connection termination, no, performing DOS attack is not legal. It's illegal. Performing any attack is illegal. Only you are allowed to perform that attack if you are doing ethical hacking. Ethical hacking is like the company has hired you to find out the vulnerabilities and loophole in their security system, or you are an ethical hacker, you are just testing their sites and everything, and if you are finding any loophole, you are going to those company without misusing that information, you are going and telling them that these are the loopholes, you can patch these vulnerabilities, these are the security loopholes in your system. Okay, but for that you should be certified ethical hacker. Okay, so performing any sort of attack is illegal. See, generally these attacks are performed by these competitors. Okay, and sometimes for this what we'll say ransomware also. So suppose we take example. See, now this Amazon and all, they are having high layer of security and their servers are very strong. But suppose Amazon is on the sale. Okay, it announces that sale for 5 days sale. Okay, and you know that when it is a sale time, the people buy a lot of stuff. Okay, so they earn a lot from that period. So if you put that server down even for 2 hours, so what a loss for the Amazon. Okay, for that particular organization or company, which is if the server is down, if the customers are not able to place the order. Okay, so the competitors can put their servers down. See, generally these Amazon and all those things, they don't perform here because that those are very well known things. But the organizations which are not very well known, they are in the working in the similar sectors and they are competitors. So there this can be performed by their competitors, or sometimes the attackers also. Okay, they perform the DOS attack, or they put their servers down, their services are not available. I think some time back Google was not working, Gmail was not working. Okay, so definitely it was not that Google was not working, that server was not working because it was having a lack of resources or something like that. It was not because of that. Okay, you must have heard now that the Google server was down. Okay, so imagine that that somebody
Yes,
was
ma'am.
able to put the Google server down, how much security they must be having, how much backup they must be having, what capacity they are having of the servers. And if you want to perform this a DOS attack, if you are continuously sending SYN this request from one machine, you continue to send for thousands years, nothing is going to happen. Okay, for that you have to send this collective information from thousands of your attacking process should be like that. In 1 second it sent thousands of requests. Okay, then either you can use spoofed IP, or you make other machines as your bot, and you take control of them, and every machine start sending the information. Even that ping request now, ping, that is used for attacking. But generally now that systems are smart, they don't respond much to that ping. If you ping to window now, after 4 5 that ping reply, it will stop automatically. Okay, it will not reply you more than that. So if your machine is continuously pinging, you are continuously pinging from 10,000 machines, and then definitely that server is replying to those ICMP, sending ICMP packets, and that server is not able to provide services to the legitimate user. Okay, so that is also used, but for that you need a lot of resources. Either your system, your software that which you are using, that should be strong enough that you can transmit thousands of requests per second. Otherwise you attack other machines, you make them bot, you make them your illegal bots, and you instruct those machines to send the request, thousands of requests per second. So if 10,000 machines sending 1,000 requests per second to any particular server, then definitely that server will be down. But for that, the person should be, what we'll say, need highly skillful. Okay, or you should have a particular proper group, and those who are expert in their this attacking domain. Now this connection termination. So again, in the connection termination, there is a process of three-way handshaking. Okay, so in three-way handshaking, connection termination, we are using FIN flag. Okay, FIN flag. So here, if this is my client and this is server, now we are done with the data transmission. Now we want to close the connection. Okay, for closing the connection, what this client will send, it will send a FIN segment. So whatever is the sequence number, whatever the sequence number it was sending, whatever the acknowledgement, I'm taking X and Y. Okay, because I don't know what till what data they transmitted, so we are just assuming that X and Y. Now in this, it will set acknowledgement flag to 1 and finish flag to 1 and send here. Okay, now the server has received this uh, fin segment for closing the connection. Now server also want to close the connection, it is ready to close the connection. So it will reply. So here it will use a sequence number Y and acknowledgement number of whatever it received, X plus 1, and then it will set acknowledgement flag to 1 and finish flag to 1. Okay, and it will send this to the client. Okay, so this we call it as a FIN plus ACK. Now this client will reply to this. So it is only a acknowledgement sequence, so it is not going to use a sequence number. So same sequence number, then acknowledgement number is Y plus 1 because this was a Y. Okay, and then it will set that acknowledgement frame to or flag to 1 and transmit it. Now connection is closed. So this is ACK segment. So now connection is closed. Okay, so here it is active close because it is requesting to close the connection. So active close. This is passive close because it accepted, it is ready to close that connection, passive close. Okay, and now it is the finally connection is closed. So this is three-way handshaking for connection termination. Now in this, there can be half close also. Okay. So this we call it as a three-way handshaking or connection termination. Now this connection is closed from both sides, from the server and the client side. If they both are communicating, they're transmitting the data, okay? And one side, the client wants to close the connection, but server is still transmitting the data, okay? You are downloading something or still that server is providing you data. So that time, the connection will be closed from the client side, but from the server side, the connection will be open. So that we call it as a half close, okay? So what is half close connection? So again, with the help of diagram, we'll see. So this is client and this is server. Now client wants to close the connection. Okay. So client will send with a sequence X, acknowledgement Y, and it will send that acknowledgement flag 1, finish flag to 1, and send it to the server. Okay. Now server is not ready to close the connection. It is still sending something. Client is still downloading. So it will not set this finish flag to 1. It will just acknowledge this flag. Okay. So the response for this machine will be sequence y minus 1. Okay. Because sequence, whatever is the previous one, the next segment it is sending sequence, then acknowledgement is x plus 1, because it is not going to use it is just an acknowledgement flag, so that's why it is not going to consume any sequence number. So whatever it is having that previous sequence number, that same it is going to use y minus 1, and it is set acknowledgement flag to 1 and transmit. Now this is half close. Okay, the connection is closed from the client side but not from the server side, and this will continue to transmit the data. Okay, and this client will continue to send the acknowledgement. So data transfer will, or data segments will be continuously going from server side, and this client is not able to send any data, just sending the acknowledgements. Okay, acknowledgement segments. Now once the server is done with the data transmission, then it will send the sequence to close the connection. Okay, now suppose it has transmitted the data. Now the sequence number is Z, acknowledgement number is the previous one, whatever it is, the x plus 1, and now it will set the acknowledgement flag to 1 and finish flag to 1, and it will transmit. Okay, now this client will reply with the acknowledgement, and then connection will be closed. Okay, so sequence X, because it is just acknowledgement, and acknowledgement number is Z plus 1, and this acknowledgement flag is set to 1, and now this connection is closed. Okay, so till this is a half closed connection. After this is a complete closed connection. From one side the connection was closed. Yes, समझ में आया? What is this half close connection? Any doubt in this? Yes, no? Should I repeat something from this? Connection termination or half close? Hello? Is this clear?
Yes, ma'am.
Okay, yeah. So that is about three-way handshaking or TCP connection thing. Okay, TCP connection thing. Okay, so it has, TCP connection has three things. Connection establishment. In connection establishment, we use three-way handshaking. Then data transfer, and then connection termination. Connection termination again have three-way handshaking, and connection can be closed in half side, from the one side only. So that is a half close. Okay. So this is, we can call it as a half close. Okay. Hmm. All these things, what the terms which we are using now, they are going important for Viva. That what is half close, what is this three-way handshaking, uh, is SYN segment going to use sequence number, is FIN segment going to use sequence number, is sequence number required for ACK segment, all those things. Okay, these things can be asked in the Viva. Okay. And if in the exam, this three-way handshaking also, sometimes this is asked for 10 marks or sometimes for short note. Okay, so then you have to explain this three-way handshaking process with the complete diagram. Okay, like this. Hmm. Now flow control. Okay, I told you that TCP is reliable connection. It means it provides flow control, it provides error control. Okay, so how this flow control is maintained in TCP. Okay, flow control, how it provides flow control. Okay, so if you remember flow control in data link layer, so in the flow control in the data link layer, there were sliding window protocol, if you remember. Sliding window protocols. Can you tell me the name of those protocol? Anyone remembers the name of those sliding window protocols? Anyone remembers? There were two sliding window protocols.
Move back.
Go back and yes, and one more was there. So one was go back and another one was, anyone remembers the name? Selective repeat.
Selective repeat.
Yes, selective repeat ARQ. याद है वो? Go back and ARQ, selective repeat ARQ. Okay. In go back N, there is no negative acknowledgement. Okay. And the receiver is not going to receive the data which is out of sequence. So if you are sending the frame at the data link layer, we send the frame na. So frame number 1, 2, 3, 4, like this you are sending, and your frame number 3 is lost. Okay, in both there were window size, if you remember, there were window size. ये go back n का window size याद है? Sender and receiver side में window size था.
Yes, ma'am.
Sender and receive. हाँ, क्या था उसका window size? Sender का
2 raised to n.
2. Okay, and receiver का window size था 1, because it is not going to receive out of sequence. So if you are sending, suppose the window has 4 frames, so 1, 2, 3, 4, you can transmit those frames without waiting for the acknowledgement. Okay, and suppose you transmitted your frame number 1, 2, third was lost, so the receiver is waiting for your frame number 3 only. So it will discard all other frames which you are transmitting, it will discard them. It is waiting for the frame number 3, so it will wait for that frame number 3 only. And then when the timer will expire for this go back n, the sender has to retransmit all the frames starting from the frame which was lost. Okay, so the frame number 3 was lost, so frame 3, 4, 5, whatever frame you transmitted, after that you have to retransmit them. So that's why go back and in selective repeat there was a negative acknowledgement. Okay, it received the segment out of sequence also. Okay, so here window size was 2 raised to power m minus 1, and the receiver side also 2 raised to power m minus 1. Okay, so if you are sending the segments like 1, 2, 3, 4, 5, and your frame number 3 is lost, so here this receiver side will accept the remaining frame also. If they are coming out of sequence, it will continue to wait. If you are not receiving the 3, so it will send negative acknowledgement for 3, that I have not received your frame number 3. So then the sender will retransmit, so it will wait for that. When it is received, then it will deliver to the higher layer. Okay, so that was the sliding window protocol of data link layer. In the TCP also we are using the same protocols. Okay, but the combination, so sliding window protocol of TCP is a combination of both, because it is like go back and because it is not going to provide negative acknowledgement, but it is like selective repeat because it accepts the frame out of sequence also. You don't have to retransmit all the segments which were lost. Okay, so you can say this sliding window protocol of TCP accepts the frame out of sequence like selective repeat, but it does not provide any negative acknowledgement. So you can say it is like go back and also. Okay, so it is a combination of both or mixture of both, or good things, selective things of both are taken. So that is a sliding window protocol which is used in the TCP flow control. Okay, again here the window size will be there same way, but here window size ka criteria will be different. Okay, so similarly, if you are having n minus 1, this, all these frames are segments are already transmitted, then n plus 1, then like this, and suppose still m minus 1, m, m plus 1, something like that. Okay, so if this is the window, if this is a window, okay, in this again, this window, like these segments which are inside the window can be transmitted without waiting for the acknowledgement. And every time we receive the acknowledgement, you can slide the window. Okay, you can slide the window. So this side you can close. You can say closing the window from this side if you're sliding, and this side you are opening. Okay, so when you are sliding this side, okay, so if you receive the acknowledgement for these two, then you can slide the window by 2. So now the next two segment you can transmit without waiting for the acknowledgement. Okay, and here window size. What is the window size? Window size is minimum of minimum of receivers window size and congestion window size. Okay, receiver advertise its window size based on its buffer capacity. Okay, how much segment or how many bytes of the data, basically not it is not segment wise, it is byte wise because it is a byte oriented. So how many bytes of the data it can store on in its window, it advertise. So when it sends the segment here in the data transfer, so here this can advertise. So if this is replying now here, so along with this it will tell receiver window size is 2000. It means it has a buffer capacity of storing 2000 bytes only. Okay, so accordingly this client will have a window size which contains only 2000 bytes which can transmit. Okay, it will not transmit more than 2000 bytes in one window. Okay, so that is receiver window size. This is received from the receiver. If you are transmitting to the destination machine has a buffer capacity of 5000 bytes. So it will tell that my window size is 5000 bytes. So the sender will set its window size to 5000, and it will send 5000 bytes only before waiting for the before receiving the acknowledgement. It will not send more than that, because that can receive only 5000 bytes. Can store the 5, otherwise all that extra data if you're sending, that will be lost. Then this congestion window size is provided by the network. If there is a traffic in the network, if there is a congestion in the network, so that network will provide you that in the network you send only 2000 bytes. Network cannot handle more than 2000 bytes at a time. Okay, so then minimum of whatever, so the sender receives both values, this receiver window size from the receiver and this congestion window size receives from the network, and whatever is the minimum value of that, it will set the window size to that. Okay, समझ में आया इतना? receiver can be receiving the information from multiple resources. So if this is my receiver, okay, 3000 for this machine. Okay, so all machines still 1000 in the buffer if it receives connection from a new machine. Okay, so it will never advertise its complete window capacity. It just advertise how much capacity is allocated to this particular machine. Now, if the receiver window size of a host A for host B has a buffer size of 5000, so host A उसके पास buffer size कितना है? Buffer size which is allocated to host B is 5000 bytes. Okay, and 1000 bytes received. Now A is a receiver. Okay, A is a receiver. So buffer capacity उसका है 5000 bytes. And it is this is for B. This is for B. It is communicating with the B machine. Okay. Now B transmitted 1000 bytes का data. B ने 1000 bytes का data transmit किया. Okay. So now buffer A के पास कितना buffer capacity बचा? 4000 bytes का. So next time जब ये इसका acknowledgement देगा ना, when this A will provide acknowledgement for this 1000 bytes received, it will advertise that now I have a capacity of 4000 bytes only. So you don't send more than that. So next time B again can 1000, 1000, 1000. Once it has sent 4000 ना, उसका window का size कितना रहेगा? 4000. A B का window size 4000 bytes का रहेगा. So it can send only 4 segments of 1000, 1000 bytes. Okay. दिस इज अ विंडो साइज. और जब तक इसका एक्नॉलेजमेंट नहीं मिल जाता, एक्नॉलेजमेंट मीन्स द प्रोसेस हो गया डेटा, सो देन इट कैन जस्ट स्लाइड द विंडो. So every time this A will advertise its window that this is my buffer capacity. You don't send more than that. So this is one example. Now, suppose the second example is window size for host A. The receiving window size A B has received 3000 bytes. Congestion window size is 3500 bytes. Okay, नेटवर्क से उसको कंजेशन विंडो साइज जो है वो रिसीव हुआ है. कंजेशन विंडो साइज रिसीव हुआ है 3500 एंड रिसीवर से विंडो साइज रिसीव हुआ है 3000. तो विंडो साइज क्या रहेगा फाइनली फॉर बी? बोलो क्या रहेगा विंडो साइज? Which value will be set as a window size by the host machine? If 3000 received from the receiving window size and for congestion window size is 3500. बोलो भाई. क्या नहीं समझ में आया? हेलो, व्हाट हैपेंड? सो गए क्या सब लोग? हेलो, एम आई ऑडिबल? कैन यू हियर मी? What will be the window size? Minimum of whatever value is there. What is the minimum out of 3000 and 3500? So 3000 is the minimum value. Okay. So it will set the window size to 3000. Yes, window size is 3000. Okay. Now that was a flow control in TCP. Now error control in TCP. Okay. Error control in TCP. जो हम पढ़ रहे हैं वो समझ में आ रहा है ना, या ऐसे ही हम सब अपना टाइम पास कर रहे हैं सब लोग मिलके? ये समझ में आ रहा है नहीं आ रहा है?
And can you repeat
Yes,
the
ma'am,
last part
understanding.
again?
Which part, beta? Window size.
Yes, ma'am.
See, window size is the number of bytes we can transmit without waiting for the acknowledgement. But the window size in data link layer was dependent on the number of bytes we were using for the sequence number, okay, on that m value. But here the window size is depending on these two factors. Receiver tells its buffer capacity, okay, to the sender, that this much byte I can store in the buffer, because that it takes time for the processing, okay. And the congestion is window is given by the network, because TCP have congestion control also, that we are going to discuss in the next lecture, okay. So the network also advertise, because network, if you are transmitting 10,000 bytes continuously per second, so if there is a congestion in the network, so your data will be lost on the way. So network will tell you to slow down, don't send so much of the data, otherwise the data will be lost, okay, because this is a reliable connection. You remember हमने वो राउटिंग प्रोटोकॉल किया था, राउटिंग प्रोटोकॉल का सिमुलेशन किया था इन लैब में. सो जो बीच वाला जो नोड था, राउटर था, उसको जब दोनों साइड से आ रहा था तो एक्स्ट्रा जो जो भी इंफॉर्मेशन आ रहा था, इट वाज ड्रॉपिंग दोस पैकेट्स, ओके. सो टीसीपी में ऐसा नहीं होगा. टीसीपी में अगर कोई पैकेट ड्रॉप हुआ है तो उसका एक्नॉलेजमेंट भेजना पड़ेगा उसको, ओके, एक्नॉलेजमेंट भेजना पड़ेगा. और अगर पैकेट जब तक उसका एक्नॉलेजमेंट नहीं मिलेगा, सेंडर वो पैकेट रीट्रांसमिट करता रहेगा, ओके. सो दैट्स व्हाई the receiver will tell its window size, congestion the network will tell its window size, कि इतना capacity है तुम्हारा भेजने का. So accordingly that sender will set its window size, and if the suppose window size is set to 3000, so it means it can send 3000 bytes in the window without waiting for acknowledgement. Okay, let me explain this thing with one more example. Okay, suppose अभी सेंडर का ये इंफॉर्मेशन है, ये बाइट भेज रहा है, ओके, बाइट बाय बाइट भेज रहा है. सो एरर कंट्रोल हम बाद में देखते हैं, पहले इसका एग्जांपल देखते हैं. सो सपोज ये जो डेटा है सेंडर का, सेंडर के पास है. सो व्हाटएवर द इंफॉर्मेशन, सपोज बाइट नंबर 199, 200, 201, 202, 203, 204. This is the byte by byte. It is sending the information byte by byte. That's why TCP is byte oriented. 206, 207, 208, 209, and something like that. Okay. And ये इसका बाइट है टीसीपी के पास भेजने के लिए. एंड सेंडर ने यहां तक का इंफॉर्मेशन ये ऑलरेडी भेज दिया है, बट एक्नॉलेजमेंट नहीं आया है. ओके. सो यहां तक का जो बाइट है, ये जो इंफॉर्मेशन है अपना विंडो साइज, ये जो है सपोज यहां से लेके यहां तक का इंफॉर्मेशन, ओके, दिस इज ऑलरेडी सेंट बट नॉट एक्नॉलेज्ड. ओके, सेंट बट इसका एक्नॉलेजमेंट नहीं आया है. तो जब तक उसका एक्नॉलेजमेंट नहीं आएगा, क्या करेंगे, इट कैन नॉट डिस्कार्ड दिस, इट हैज टू कीप अ कॉपी ऑफ दिस. ओके, सो ये अपना bytes है 2000 sorry 200, 201, 202. Okay, these bytes are transmitted, which is not, and this is the next byte to be transmitted. So this is next byte to be sent. Okay, this is the next byte to be sent. After that, if the window size, receiver window size is received 9 byte, okay, and sorry 20 byte, suppose receiver window size is 20 byte and congestion window size which we have received is 9. Okay, receiver ne bola that it can receive 20 bytes, it has the capacity to store the 20 bytes, but network is saying that there is a congestion in the network, you don't send more than 9 bytes without waiting for the acknowledgement. So what is the minimum of this? So minimum of this is 9. So minimum of this, the 9 is set as a window size. Okay, so that will be set as a window size. So 9 means total 9 bytes it can send. So these 3 bytes already transmitted, not acknowledged. Other than these 3, it can send 6 more. So 1, 2, 3, 4, 5, 6. Okay. So this is going to be the window size. ये window size होगा. So it can transmit these bytes, but not immediately. Like it will send this byte, then this byte, this byte. If it receives acknowledgement for this, then it can send the next byte. Okay. So this is going to be the window size. So window size is where minimum of 20 and 9 which you receive, that is 9. Okay. So this is your window size. Now these bytes already transmitted, not acknowledged, waiting for the acknowledgement. This can be next transmitted. Again, once we are done with this, this can be transmitted. Okay. And if you receive acknowledgement, then you can slide. If you receive less value any of them, then you cannot slide. Okay. You have to every time set the window size based on whatever value you are receiving. ये अभी समझ में आया ये एग्जांपल से? Yes, no?
Yes, ma'am.
Okay. Now, error control in TCP. Error control in TCP. Okay, so how error is controlled? So here, error control is, there are 3 simple tools. Okay, this error in this TCP provides reliability. It means it is providing reliability using error control. So error control is a technique which is used for if you want to find out if there was any corrupted segment, any segment lost, or any segment delivered out of order, or any duplicate segment. Okay, and in the error control we have also find out if there is any error. Are we able to find out that there is error in that? Error detection and error correction. So 3 things are used in TCP for error control, that is checksum, then acknowledgement. Acknowledgement it is using, okay, ACK, and it is using a timer, timeout. Okay, so it is using a timer, timeout, and if there is timeout, it will retransmit that depending on the sliding window protocol. Okay, so these 3 things are used for error control: checksum, acknowledgement, and timeout. Out of this checksum we have not covered in the error correction, error control part in the data link layer. So now I'm going to explain this checksum wala part. Then we'll discuss the remaining 3 things. And this checksum technique which we are going to discuss, it is common for all places. Wherever in the header part we are using the checksum, this the same way we are going to use. Okay, the same technique, same process we are going to use. So in the data link layer, if you remember, we did error correction and detection technique, Hamming code, CRC, polynomial. याद है? Okay, so out of those technique, different protocols at different places, different things are used. Mainly this checksum is used in the header part. Okay, to uh, maintain the header. So checksum is a technique. If I am sending you something, how you will find out that whatever I have sent, you have received it correct or not. So along with that, I will add those values and send the sum also. Okay, I will send a sum also. So you can calculate if I'm sending you 10 elements, 10 items I'm sending. Okay, and I'm writing a total count also, that I'm sending you 10 items. So at your side you can count if you have received 10 items, and then you can say, okay, you have received the correct information. So similarly, in the checksum, if I, this is my data which I want to transmit. So my data is 7, 11, 12, 0, 6. This is my data which I want to transmit. Okay. So if any bit is changed in the binary, so the value of this will be changed. So how that receiver will come to know that I was planning to send 7 only, not 6, something like that. So with this, I'll add these total values and send this. So here we call it as a checksum. So along with this, I'll send checksum also. So initially I have not a checksum, so I'll put 0 here. In this checksum part, I'll put 0 and add together. Okay, add together. So if we add these values, it is going to become 36. Okay, it is going to become 36. Now, can you tell me the maximum number of bytes which are required to represent only my data? How many number of bits I need to represent this data? How many bits are sufficient to represent this in binary?
4.
4. Yes, with 4 bits, we can represent all values till 15. Okay. Now 36. If you write this information in the binary, it is going to be 100, 100. And we are having only 4 bits. We are having only 4 bits for this data. How to adjust these 2 bits? Okay. With the 4 bits, we cannot represent 36. Okay. Maximum value with the 4 bits, we can represent 15 only. But the sum is more than 4 bits, 15. So what we have to do, there is a technique called wrapping up the sum. Okay. So the number of bits we are having in our data, take them and take the extra bits which are generated, extra bit, and add here, bring them here and add. So this is called as wrapping up. Okay. So wrap up this, add this. Okay. Adding is XOR operation, 0, 1, 1, 0. Okay. Now this is 6 in decimal. Take one's complement of this. Okay. So it will become 1, 0, 0, 1. So this become 9. Okay. So that is, this is one's complement. Okay. And now this is known as checksum. This is known as checksum. Now this 9 is your checksum. So replace this 0 with the 9. So now when we will transmit this data, what we will do, it will be transmitted like 7, 11, 12, 0, 6, 9. Okay, this is we are going to transmit. ये समझ में आया कैसे कैलकुलेट किया? Any doubt in this? Any doubt in this? Should I repeat any part of this?
Ma'am, checksum part will you explain?
Checksum means you add those values together. Okay, in the checksum you put, you are going to add checksum na, so uski jagah initially you put 0 because we have not calculated checksum. You keep one space for that. We are going to transmit, and all other values you add together and then convert those values into binary. Okay, so definitely you cannot represent, the sum is going to be more than the number of data, what the data which we are having. So we cannot represent 36. If you convert in the binary, it is going to be in the 6 bit. Okay, and with the 4 bit we can represent maximum 15. We cannot represent 36. So for 36, you just keep the number of bits which are maximum for this data. So suppose 4, and the extra bits which are generated, bring here in the last and add. Okay, once you are added these values, so whatever value you got, you take one's complement of that value. Okay, and the one's complement of that value, convert that back to the decimal and put that data. Basically binary में भेजने वाले हैं, तो ये सब binary में ही जाएगा. Okay, 00, 0111 and 11 and all that ना, and then you transmit. So for समझने के लिए हमने उसको decimal में लिया है. So now whatever you got one's complement, you replace that 0 with that value and this data you transmit. So देखो उसे अपना data इतना ही है जो हम भेज रहे हैं, but ये data का total क्या हो रहा है, ये हम साथ में भेज रहे हैं. This is like I want to send you 5,000 rupees, but I'm sending a note of different denominations. So if that person is not reliable, so what I'll do, on one note I will write that I'm sending 20 notes of 100 rupees, 5 notes of 50 rupees, 2 notes of 500 rupees, like that. Okay. So at the when you receive that money, you check that I have you received 4 notes of 500, have you received 10 notes of 100 rupees, like that. You can find out that all information, all amount is received correctly. Okay. If I write only that I'm sending you 10 notes, so if that person replaces that 500 ka note with 100 rupees, still it is going to count 10. So that's why I have to write everything, that 4 notes of 500, 10 notes of 10 100 rupees, like that. So you, at the receiver side, when you receive, you are assured that whatever you have received is the information which I sent you. Okay. So this is the total sum कि इतना information मैंने भेजा है
मैम
तुम्हें. हाँ.
मैम वो जो ग्रुपिंग करते हैं उसमें हमेशा 4 बिट्स लेने का।
नहीं, 4 बिट्स मैक्सिमम, इसमें कितना लग रहा है उतना लेने का, 4 नहीं लेने का. अभी मेरा मैक्सिमम वैल्यू 12 है, तो 12 के लिए मतलब 4 बिट सफिशिएंट है ना. बट अगर यहाँ पे मेरा हाईएस्ट वैल्यू सपोज करो 27 होता, तो 27 के लिए मतलब 5 बिट्स लग रहा है मेरा, है ना. तो 5 लेने का, जितना अपना हाईएस्ट वैल्यू को बिट लग रहा है उतना लेने का बस, और उससे जो एक्स्ट्रा है उसको रैप अप करने का.
यस मैम, गॉट इट।
हाँ, ठीक है. सो अभी दिस इन्फॉर्मेशन इज रिसीव्ड एट द रिसीवर साइड. अभी रिसीवर कैसे चेक करेगा कि जो इन्फॉर्मेशन रिसीवर दैट इज करेक्ट और नॉट. ओके. सो इट हैज रिसीव्ड 7, 11, 12, 0, 6 एंड 9. ओके. सो वो क्या करेगा, इट विल एड अगेन. सो आफ्टर एडिंग इट विल convert that into the binary. Okay. So if we again 45 in the binary, it is going to be 1 0 1 1 0 1. Okay. So again, take the extra bits, 4 bits only represented. So take those extra bits, add. Okay. So now we have added. So it became 1 1 1 1. Now take 1's complement. 1's complement of this sum. So it became 0 0 0. So if your sum is 0, it means your information is received exactly. Okay. This is 9, मतलब हम माइनस भेज रहे हैं ना. 9 मतलब माइनस भेज रहे हैं. सी, अगर ये देखो इन्फॉर्मेशन, ये बाइनरी का छोड़ो, एक बार अपना नॉर्मल वे में देखो. नॉर्मल वे में अगर मेरे को ये आई हैव टू सेंड 7 11 12 0 6, सो इसका टोटल होता है 36. सो इफ आई सेंड 7 11 12 0 6 माइनस 36 मैंने साथ में भेजा. वंस कॉम्प्लीमेंट माइनस ही तो होता है ना. तो रिसीवर साइड में तुम क्या करोगे, 7 11 12 0 6 एंड माइनस 36, इसको ऐड करोगे. ये माइनस है, बाकी सब प्लस है, तो क्या आएगा, 0 आएगा ना. ये पॉजिटिव है, ये नेगेटिव है, तो ये 0 आएगा. 0 आया मीन्स करेक्ट है. सो सेम चीज ही कर रहे हैं. वंस कॉम्प्लीमेंट उसका मतलब नेगेटिव भेज रहे हैं उसका. ओके. तो कन्वर्ट दैट टोटल सम, रैप अप whatever value you are getting, take one's complement, and if you that value you are getting 0, it means you have received information correctly. Okay. There is no error. समझ में आया.
यस मैम।
ओके. डाउट है कुछ.
नो मैम, क्लियर।
Okay. So this is the checksum technique, and this checksum technique is used in the same way, similar way. Okay. So if I'm sending you a text, like I'm sending hello, how are you? Okay. So then what I have to do, I have to write this hello, how are you in the binary. Then I can convert that into the hexa value or whatever, and then I'll add those values and wrap up and send. Okay. Whatever information we are sending, just add that value, wrap up, take one's complement, and that one's complement you send. So checksum, wherever in the header part we are using the same technique. So header ka info checksum, if you have to calculate, so all the values of the header, take all those values, add together. Okay, wrap up that, take one's complement and send. So that's why checksum is used. So this in the TCP control, checksum is used. That is one technique for error control. Okay. Other two techniques we'll discuss in the next lecture, because for this timeout we need to study different timers, and then this acknowledgement, there are two techniques of this acknowledgement also. Okay. So we can wind up here. When is term end? क्यों बेटा थक गए क्या? बहुत हुआ शुभम, पढ़ पढ़ के बहुत हुआ, बस टर्म एंड करो. हाँ, ऐसा है क्या? अभी term end is I think on 19th of May. Okay. ITA 2 इज फ्रॉम 3rd May, जो 3rd May वाला जो वीक है ना, उसमें है। सी टर्म एंड तभी होगा सबका जब सबका सिलेबस खत्म हो जाएगा। सी इट कैन बी बिफोर योर ITA 2 और इट कैन बी आफ्टर योर ITA 2। तो सभी सब्जेक्ट का टर्म एंड तभी होगा जब भी सभी सब्जेक्ट्स का सिलेबस कंप्लीट हो जाएगा, सब असाइनमेंट्स तुम लोग सबमिट कर दोगे, सब एक्सपेरिमेंट्स तुम लोग सबमिट कर दोगे। ओके, सब एक्सपेरिमेंट्स लैब के कंप्लीट हो जाएंगे। सो उस सब्जेक्ट का उस टाइम टर्म एंड हो जाएगा। सो अलग अलग सब्जेक्ट का टर्म एंड अलग अलग होगा। अगर किसी का सिलेबस 19 मई तक भी नहीं होता है तो भी वो टर्म एंड नहीं होगा उस सब्जेक्ट के लिए, वो कंटिन्यू चलता रहेगा जब तक वो चीजें कंप्लीट नहीं हो जाती है। सो अभी वो तुम लोगों पे डिपेंड करता है कि हर पर्टिकुलर सब्जेक्ट का टर्म एंड कब होता है। ओके, जब तुम सब लोग अपना काम कर दोगे, सबमिशन हो जाएगा तो टर्म एंड हो जाएगा। अभी मेरा सिलेबस अगर हो गया नेक्स्ट वीक में, सब लैब हो गया और तुम लोगों ने सब सबमिट कर दिया, तो फिर हम क्या करेंगे? छोड़ दूंगे ना तुम लोगों को फ्री। उसके बाद तो कुछ रह नहीं गया ना अपने पास करने के लिए। गेटिंग? सो ऑफिशियली टर्म एंड तो है 19 मई को, बट सब्जेक्ट वाइज अलग अलग होगा। तुम लोग कब सबमिट करते हो उसके ऊपर सब कुछ। ओके, लैब असाइनमेंट हैंड रिटन नोट रिक्वायर्ड। ओके, उसका PDF भेज सकते हो। थियरी असाइनमेंट और जो असाइनमेंट जो मैंने दिया है फास्ट लर्नर वाला, वो दोनों हैंड रिटन है कंपलसरी। ओके, थियरी असाइनमेंट एक दिया है, एक और देना है। अभी अपना सिलेबस पूरा हुआ नहीं, इसके लिए एक और देना है। So only theory assignment and the assignment for fast learner should be handwritten. Remaining everything document चलेगा। Okay, PDF भेज सकते हो। We have to be in book. Which assignment is in the book? क्या पूछ रहे हो शिवम? I didn't get your question. फास्ट लर्नर वाला, हाँ बुक में, नोटबुक में, पेपर पे कैसा भी सॉल्व करके उसका फोटो चाहिए मुझे। उसका गेट के पेपर्स मैंने भेजे है ना, वो 5 क्वेश्चन सॉल्व करके नोटबुक में सॉल्व करो, पेपर पे सॉल्व करो, किधर भी सॉल्व करो, उसका फोटो चाहिए PDF। यही पूछ रहे थे या कुछ और? सी दिस ITA 2 स्टेशनरी शॉप्स आर क्लोज। अरे घर में रफ नोटबुक होगी, कुछ तो होगा। ओल्ड नोटबुक्स, रफ नोटबुक्स, जो भी है घर में, प्लेन पेपर्स, कैसे भी पेपर्स। ओके, हाँ। सी मोस्ट प्रोबेबली योर ITA 2 कैन बी subjective plus objective. Okay, it could be like your semester theory exam, could be। Okay, possibility है उस चीज की। So prepare accordingly। ये सिर्फ MCQ बेस्ड नहीं होगा। Okay, so we'll wind up here। अटेंडेंस ले लेते हैं।